Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Shah Fahad Khan on your screen. Now guys, today there's a very big announcement that I want to make, and that is I'm gonna start out a series of lectures on AS Chemistry, complete syllabus revision in this series of lectures, and it's gonna be more like a workshop of AS Chemistry, covering all the high yield points, all the major points that you guys as AS students must know before attempting the exam, regardless of how much the exam preparation you've done. All right, and this is especially important if you guys are preparing for your exams, and if you want to review it, you can review it like a week before the exam, or sorry, not a week, like a month before the exam. Okay, the entire course would be reviewed. Okay, so let's get started now. So basically the chapter that I'm going to start out today is a chapter of the very first chapter basically, and it's related to atomic structure and inorganic, not actually inorganic chemistry, but rather the atomic structure, and the name of the topic is ionization energy. Okay, so this is the topic that we are going to do at ionization energy. All right, so let's begin. Ionization energy. So first of all, we must know what's the definition of ionization energy. Ionization energy by definition is basically the energy which we need to remove 1 mole. This is the key term, 1 mole of electrons from 1 mole of gaseous atoms. This is the second key term, to produce 1 mole of univalent, again 1 mole of univalent positively charged ions. Okay, this is the complete definition of ionization energy. All right, now let me explain what that actually means. So in order to explain, you must look at this example over here. So basically what this definition is trying to tell you is that it's basically ionization energy, as the name suggests, energy. It is a form of energy. Okay, and what sort of energy? Well, it's the sort of energy that we provide to gaseous atoms. Okay, now over here I've got magnesium atoms in the gaseous state, and 1 mole of magnesium atoms are used. Okay, this is just 1 mole of magnesium. Now 1 mole of magnesium, we provide energy to that mole of magnesium. And what that energy does is it accelerates the electrons, or it excites the electrons, and the electron, 1 mole of electrons in this magnesium atom, they absorb the energy, and that energy is high enough for that electron to leave this magnesium atom and go away, leaving behind magnesium ion. Okay, and why is an ion formed? Because it has lost 1 electron. A negatively charged species is lost, right? A negative species is lost. A -1 charge is lost, so it will gain a +1 charge, right? Because the protons have exceeded the electrons now. So now look again, and this time this definition is going to be crystal clear, and it will be in your heads. Now the energy that we provide to 1 mole of gaseous atoms to produce 1 mole of univalent positively charged ions. Why univalent? Univalent, what does univalent term means? This term univalent, uni means 1, right? Uni, same thing, and valent means valency, the charge on it. So the charge, so univalent means +1 charge. It's positive and it's univalent, meaning having a charge of +1. Okay, this +1 is a charge. Is it the charge on magnesium? Yes, it is. So that's the charge on magnesium, forming 1 mole of univalent positively charged ions. Okay, removing 1 mole of electron, forming 1 mole of univalent positively charged ions. So now to sum it up, ionization energy is the energy that we provide to an atom to remove 1 mole of electron from it, forming 1 mole of positively charged ions. Okay, and now if I provide further energy to this gaseous ions, to this univalent positively charged ions, if I provide more energy, and if I remove another electron from it, another mole of electron from it, then I'll get a divalent charge, a divalent ion, basically a positively charged divalent ion. Now this time, since the charge has become +2, this energy that I provided will be called second ionization energy. Okay, and another electron has been removed. If I were to show it to you in a diagrammatic form, so you guys know what an atom looks like, right? This is the nucleus of an atom, and these are the electron shells, the principal quantum shells around it. Now, there are 2 electrons in the first shell, and let's assume there is 1 electron in the third shell. In the second shell, and these are all the electrons it has. So can you guess what element this is? This is lithium, right? It has 3 electrons. Now, if this is lithium, this is the outermost electron. Remember, this ionization energy is absorbed by the electron that would require least energy to escape, okay? I'm repeating, the ionization energy is provided to the electron that will require the least energy to escape, meaning the electron that's since you guys know electrons are negative and the nucleus is positive, so there is an electrostatic force of attraction between them, right? The electron that is far apart, that is the farthest apart from the nucleus, will be most weakly attracted to the nucleus, right? And the one which is closest to the nucleus will be the strongest. The strongest attraction will exist between that electron and the nucleus. Now, since this electron is the outermost electron, it will require less energy, so that ionization energy will rapidly or immediately be absorbed by the outermost electron. So now, in this way, the energy that I provide to this outermost electron to escape, okay? The energy I provide to this outermost electron, this electron will gain energy, and it will use that energy to overcome this force of attraction, and it will escape out. This energy will be called the first ionization energy, okay? And you will get an ion, okay? This is the nucleus, and this time now it will only have 2 electrons left with a positive charge because it has lost 1 electron, okay? And this is your electron, and this ion is univalent and is positively charged, okay? And so now this time this energy is called the first ionization energy, first IE. Clear? Now a few characteristics or a few properties or a few important points that you must note regarding ionization energy. It is always endothermic. Endothermic means it will always absorb energy, okay? In simple terms, or if you want to see the definition of endothermic means that the energy absorbed in bond breaking is greater than the energy released in bond forming. That's another definition that you guys might have learned in your O levels. But endo means absorbing or taking in. So endergonic is a synonym for endothermic reactions, okay? Endergonic, it's also called endergonic. Now it's always exothermic, it's always endothermic. The first ionization energy is always endothermic because it uses energy to break the bond, okay? To break the bond between this attraction. To break this attraction, we require energy, right? To break this attraction between the electron and the nucleus, energy is required. So in order to break this, we require energy, so that's why energy needs to be absorbed by that atom, by that electron, so that it could escape. Therefore, since we need energy to break this attraction, so therefore this ionization energy also gives you an idea of how strongly this outermost electron is bounded to the nucleus, okay, as I explained it right over here. So the greater the ionization energy, the more difficult it is to remove the outermost electron. That's it in this lecture, guys. In the next lecture, we'll be talking about the trends of the first ionization energy in the periodic table. Thank you.